Now here we have what? We have factoring trinomial. Means that we have three terms, as I told you, trinomial, and we need to factor in it. So you have two parentheses. You have first and the second, and do not forget to check your answer, because the middle term is very important. The second term should be when you factor in this, when you have two parentheses, the second term should be shouldn't be disappear, should be the same, should be equal. So for example, I have x squared, example number 7 in your page 23, example 3 7 page 23. You have x squared plus 7x plus 12. Now I want to factor this one because I have trinomial. Do not forget 1 2 3, so we have trinomial. So, and the question say factor this one, means that I need the two parentheses. So we factor the x to here and there. How about the sign? I say addition multiply addition, I will get addition, or positive by positive, positive, and positive by positive, sorry, and here from this part, and also positive by positive, I will get a positive. So do not forget about the sign of the brackets or the parentheses. So that's why I say x to x, x, and positive by positive, positive, positive by positive, positive. Now I am factoring 12 to some numbers that the difference between them or addition is equal to 7. So do not forget about this. Now factoring 12, maybe 1 to 6, maybe so sorry, we have addition here, so just addition. So maybe 1 by 12, I have 1 by 12, or 2 by 6, or 3 by 4. Which of these one, plus and negative, is equal to 7? In that case, of course, we have addition. So which of them, addition two numbers is equal to 7? Which of them? 112 is equal to 13, 2 6 is equal to 8, so 3 4 is equal to 12. Okay, so is equal to 7. That's why we put 3 and 4 here. Okay, I will repeat it for you. I have x squared plus 7x plus 12. Maybe it's easier for some students, maybe for the others difficult, so that's why I will repeat it. We factor x to x. The second, the important is sign, so positive by positive, positive, positive by positive, also positive. Now I have a 12. I'll factor 12 sheetal. So which number is equal to 12 if you multiply? So I have what? I have 1 by 12 is equal to 12, 2 by 6 is equal to 12, 3 by 4 is equal to 12 also. So which of them, if you add, let me see for all examples as a general case, if you add or subtract is equal to 7, which of them? So 1 plus 12, 30, 2, 6, 8, 3 plus 4 is equal to 7. That's why we put 3, 4. If you want to check your answer, so multiply 3 for sure, to be sure that the second or the middle term, the second term is correct, you get the second term. So add 2 nears, 3 and x, so 3 by x, I got 3x, and multiply 2 farthest one, so I have what? I have 4x. Now add them, I get 7x, with the middle term or the second term. So the example number 7 is really simple and help you to deal with the this trinomial and how to factor the trinomial. Now try to solve this one. Now I'm helping you for solving these example. So I have what? I have 6x squared, example 8 in page 23, 7x minus 5, example 8, page 23. Okay, now how we factor this example? First of all, I'll put 2 bracket, and I'll do this one as a x and x. Now how about 6? I'll tell you later. How about the 6? I can write down like that, 2 by 3. Am I right? So because 6 is equal to what? We can say 1 by 6 or 2 by 3, right? So, or 3 by 2, they are not different. So I factor the 6 to be, the 6 to be 2 by 3, and I factored x to be x and x. Now how about the sign? So addition or positive, multiply positive, I will get positive. How about the second? Positive multiply by negative, I get negative. That's all. How about 5? How we factor 5? As you know, 5, there's nothing to factor it. So just I have 1 by 5. Maybe I put here, maybe I put there. I don't know. So for checking yourself, you did this one in the correct way or not. You are right or not. So we multiply the nearest, I get 3x. And we multiply the farthest, so negative 10x. Now add them, negative 10 plus 3, you get negative 7x. Is the middle term? No. So what's the problem? What's the problem? I have a 7, but now I have a negative 7. So the problem is easy. Just put it here, 5. No. Just change the sign. It's okay. Means that you put it here first and the second. So just change the sign. Now multiply it again. So I will get 3 by 1 is 3x. Negative, sorry. Positive by 2x, I get what? 5 by 2, I get 10x. Now add them, you will see is equal to 7x with the second term. So means that x square means that x square in the page 23, x square 5x minus 5, it can be factored to that one, which we get the second term. Also he did it by the other part, or you can do it as you like, and you can use any methods that's easy for you. Really I don't care about the method, I care about the logic thing that you solve it by it and it's not false true. So try to use anything that you like it. Again we have this example. So I have trinomial. Cancel this example, please. Cancel part B, example 9, and I am solving this example, or maybe I will leave this one for you as a homework. So try to do, it's not difficult. X by x, negative by positive, negative, negative by negative, positive, and I have 3 by 1. It's easy. Okay, so forget about part B. Okay. Also we have special or quick or like a snap formula for the factoring. Do you remember we have a special case or formula for multiplication? Now here we have a special formula for what? For factoring. So this is where if we have two things, they are both of them square, we say difference between two squares. So difference of squares or between two squares means that جیاوازی نێوان دوو دووجا جیاوازی difference دووجا squares. So جیاوازی نێوان دوو دووجا difference between squares, okay, or two squares. How about this formula? As we see as a perfect square or complete square. Perfect or complete square, we have two rules which they are we called as a دووجای تەواو, perfect square, دووجای تەواو, or complete square. Some books say that we have a complete square instead of saying perfect square. Okay, they are the same. So in that case we have what? If I have first square my plus 2ab b square, if you recognize these two is what? They are the other side of formula of multiplication. I'm bringing it for you to recognize them. That's why I say do not try to memorize them, because this is what? This is the complete square, first square, and so if I have this part I can say we have that one. Otherwise if I have this part I can say I will get that part. So that's why I say Do not memorize them, just try to solve a lot of examples because you will deal with that. So this is for the difference. Here we say sum square or square of sum and square of difference. Now I have complete square for addition or sum, complete square for negative. So it means that if in case I have that one, I will deal it with that. If I wanna factor them, I will do it like that. But here these one, they are new. Okay, this one also is, they are not new. You can check it in the first formula of multiplication. So these one, they are new. This is what? This is addition and subtraction between what? Between two cubes. So difference between two cubes and sum of two of cubes. Difference of cubes or sum of cubes. When I say cubes, I mean two. Okay, dear. So that's all that we have. In that case, we will multiply. We will factor this formula as a small and large, binomial and trinomial part. So first we say a, because I have a minus, we say a minus b. Look, we say a minus b. I will show you a formula because later we will solve an example on it surely, and if it's not clear, please ask me during the meeting. So a cube minus b cube, I say we have a difference between cubes or difference of cubes. So I will put this binomial and the trinomial parentheses. In the first, the binomial, just I will write down b minus a, okay, without any cube. So I have b minus a. So here I have b minus. How about addition? The same, b plus b, a plus b. Now for that one, forget about here. I say a square minus ab. Do not say 2ab. It's not the complete square. It's not that one. So I say what is equal to a square. I have negative, so I will change it to the opposite sign to positive. So I say a square plus ab, b square. Here I have a plus b. I will say is equal to a square negative here, because I will change it here to negative, and here also is positive. Do not forget about that. So a square minus ab plus a square. This one I will deal with it with the example, not by memorizing them. So that's why now I have this one. I'm going to direct it to the example 10 in your page 24, which there are very important formula to how to use this one, how to deal with that all special formula about them factoring without memorizing them, just practice. So here's a 4x square minus 25. Okay, dear. So how we deal with that one? I will say I have a square minus b square. A is equal to what? I will say is equal to 2x square. Can you see? Why? Because I have 4x square minus 5 cube. That's why I say it's a difference of cubes. Sorry, difference of squares. Square, first square, difference second square. Okay, first square, second square. How? Like that. So I'll say directly by the first formula or anything that you say we want to say, factor this one to 2x, 2x, positive, negative. 25 will be changed to 5. Okay, dear. That's all that you need to deal with that one without memorizing. How about this one? Look, b. I have x plus y, all of them square, minus z square. I don't care. I say I have two term, square, square, between them difference. So this is difference of what? Of squares. So I will say we have a two brackets, negative, positive, positive, negative. First one, second one, second one. That's all. Okay, so what is this? Is x plus y. I don't care, x plus y, it be anything. I say first one plus that, this second one. That's all that we have here in b. If you don't understand, practice these exercises. Now it's time to go or to check page 25. Okay, we find page 25 and solving more example about this formula that we deal with it in the previous page. So I have what? 27, example 11, page 25, I have 27x cubed minus 1. So what did this tell me? Think about it. What we have? We have, this is the cube and this is the cube. How? Is equal to 3x all cube. I know because 3 cube is equal to 25. Now I have negative and I have 1 cube. That's why I say difference of cubes. So in the difference of cubes, in the same rules, we have binomial and trinomial. Okay, we have difference. I'll put what? I'll put difference, as I told you in the this formula. Now I'll say first, second, and we say first square. Okay, first square minus, I will change it to the plus. Okay, AB, so means that 3x by 1 is equal to 3x. Always plus second square, 1 square, is equal to 3x minus 1, 9x squared plus 3x plus 1. That's all that I have. Why? Because I applied, now I don't know, number 4 or 4th or 5th formula with what? With a cube difference between two cubes. Now example 11, part B. Tell me, I have x to power 6 plus 8. What is this? What is this? Really, I know 8 is what? Is 2 to power 3. You should deal with that. So I have addition. How about this one? I should put 3 here. Why? Because I want to solve it by sum of cubes. So I say x to power what? To power 2. By which rule I know how to find this one? Because I have 2 a and m. I know is equal to what? A and m. Multiplication. So if I have 6, I will say is equal to 2 by 3. But I want to remains 2. So that's why I say 2, 3. Okay, dear? That's why I put here 2, 3 as we have. So now I have what? I have sum of cube. Okay? So binomial, trinomial. First and second. Sorry, 2. Okay? So now I say first square. Forget about he's a first square. We say first square. If x square, x, anything, we say square. So we will put difference sign and you see first by second. So it means that 2x square and as usual plus second square. So I will get x square plus 2 x to power 4 minus 2x square plus 4. That's all we have. Okay, dear? I know it's not easy. There's a lot of formula in this section. As I told you, the first week and the second week will be the really more complicated because there's you need more basic things, and I'm here for you. I will do it step by step. So please try to solve all the exercise if you want to overcome or control these subjects. So how about example 12? Till here, deal with the or in this page we are recognizing and using the formula in the page 24. That's the special formula of factoring. Now I have what? I have 2 more examples about factoring. So in case I have example 12 in page 25, part A, x square 6x plus 9. So he say factor. So I have trinomial. We can use this one by two methods. The first, as I told you, use the brackets because I have two binomial. I will change the trinomial to two binomial, to 2 by, right? So how we factor x, and addition. Now I have 9. So I have 9. How we factor 9? We can say we have 9 by 9 is equal to 1 by 9 or 3 by 3, right? So I need something, the addition between them is equal to 6. So I'll choose 3 by 3. So I got this one. But you can see these two formula, these two parentheses, they are equal. So I can write down like what? Like this one, which is called what? Perfect square. So means that dujay tawa. So means that directly you can say that. Okay, you can directly say that, or you can use this trinomial to binomial. I recommend you to use that brackets because this is the general and help you to solve the other trinomials as we did it before. Now, sorry, page 25. There's about example 13. About example 13 is important also because you should do some things, then you can factor them. How? So factor means that how much? Come on. So I need you to do example 13, page 25. A. So in this example 13, I will deal with something that we need to do briefly to manipulate with it before we solve it. So you know between 2 and 8 there's a common, so that's why you get what? You get x to power 4 minus 4x squared. And you know, as I told you before, x and x squared, we will take the smallest, we will take the smallest exponent. So it remains what? It remains x to power 2 minus 4, as you know, right? So x to power 2 minus 4. And you shouldn't leave this one for me, because this one, again, when I say factor, means that do your best, or factor all things that you have. So also this is what? This is difference between two squares, or difference of squares. So this one, it remains. And how we deal with that one, as I told you, we have two brackets with addition and subtraction, and x to 2. That's all that you need. Okay, dear? So that's why I say really I like these examples. Why? Because they will give you vibration for the shocking you, because you need more experience, more examples to deal with that one. Not just doing by memorizing, but doing by using your idea. How about this one? B, part B, example 30. Example 13, page 25. We have B, x to power 5. Okay, dear. X to power 5, y squared minus xy to power x. So really I like these examples because they have many ideas in it. So in that case, we say we have what? In that case, we say between x and x to power 5, I will take x to power 4, which remains x to power 4 y squared minus y to power 6. Now it's time for factoring y. So I will get what? X to power 4 minus what? Minus y x to y to power 4. Am I right? Check it if you see there's something here. So now again and again I have two squares, even to power 4, you know, but 2 is squares. So how we deal with that one? Also difference between them. So I see, really I like this example because there's something hidden in it. You cannot see it. I will tell you later in the next page, next step. So I have x square, I have two brackets. So because the difference between two squares, I say addition and subtraction. So square root of this one and also square root of 2 1. Look, now we cannot do anything to that one. Why? Because in your lecture there is no such rules that say difference or sorry, there's no something like addition between two square. There is nothing here. Sometimes I will ask you what we haven't. So we haven't this rule. We cannot factor these. Really, we can factor between difference between them. If I have the cube to answer, we can say addition or subtraction, but with the square addition معنية, we cannot factor. So that's why that's why I say do not memorize. That's why I say we cannot deal with that one. We will just put it as we have. Nothing changed here. But in the second part of this part, I have what? I have difference of squares. So sum of squares, nothing with it. But difference also we can do it by addition and negative x, y, y. That's all that I need you to be. When I say factor, means that you shouldn't leave any steps here. Just simplify like that. Okay, that's the question of your example or exam or quiz. You can face these example. Maybe you will face these examples in your quiz or assignments. Okay, dear. So that's about page 27. Sorry, 25. And now it's time to for finishing our last page of 1.3, which was really it was page 4 section 1.3. So really more or the structure of the section is a lot, and there's a lot of information in it. So that's why I say please in this week try to study. If you see you are not controlling them, ask me during your Zoom meeting. Okay, dear, that's all. So in the last page we have two important things that I am dealing with it. First of all, I will clarify this example because easy, and I will put this one example 14 to be the last thing in our video. Factoring by group means that you have 4 terms. That's a good indicator of it for it. Yes, as I said, the difference or the grouping means that you have 4 terms. 1 2 3 4. Again 1 2 3 4. So in both examples or any other examples, you can, when I say solve, if you see we have 4 terms, so means that grouping. So how we solve grouping? Solving the grouping is like that. We have x, for example, this one, example 15 on page 26. A, say x cubed plus x squared plus 4x plus 4. So if I have 4 term, we will use the fact by group. So it means that find the common between them and them. Now I will see this is 4 4. That's why I will say is equal to, between these term I will bring out what? X squared, right? So I have also addition. I already do this bracket for just recognizing. You don't need to do it at anything else, elsewhere. So 4, I have x plus 1. Now you can see we have x plus 1, x plus 1. That's why I say I will take x plus 1 as a common. Now it remains x squared plus 4. And طبعا you cannot deal with that one because I have a square, but there is addition between them. There's no subtraction, so that's why you can leave it here. Okay, dear? That's all what you can do it. How about example B? Example B, I have x cubed, or part B, minus 2x squared minus 3x. Be careful. This one is a little bit more difficult because there's some sign you can deal with it. You should fix it. So I have between x and x, I'll take x squared, and it remains what? X minus 2. Am I right? Here, just think about here. Okay, dear? Good. How about here? I'll put addition here. I say between 6 and 3, I'll take 3. So it remains minus x, right? What? Sorry for that. So x squared, x minus 2. Now, think about here. I will take minus 3. Careful. Minus 3. So it remains x, what? Plus 6 or plus 2 or minus 2. Surely minus. Why? Because negative by negative, I'll get negative. Negative by positive, negative by negative, I'll get positive. That's why I say negative by positive, negative. Negative by negative, I'll get negative. Just be careful here. So you can see that the common things here. So I solved it by group. Here's the first group and the second group. First group, second group. So between these two groups, we have what? X minus 2 as a common. It remains x squared minus 3. Okay, dear? So this is also not square. That's why I will leave it to here. Okay, dear? This is the things that I want to tell you. Now, example 14. Many students have or will face the difficulty here. It's the last example in this section, and I need you to concentrate with me and be with me step by step. Even you don't understand, try to reply this video many times to get the example number 14, because really it's the one of the important examples itself and with the exercises. Okay, now example 14 in page 26, part A. We have 3x 3 by 2. Look, they are the same with the previous one, but the exponent here is fraction, which we recall as a rational exponent in the 1.1 and 1.2. Now, first of all, you know, between 3, 9, 6, we have 3 as a common. So 3 as a number minus 1 over 2. Okay, dear? Now, how about usual, we see that as usual, we see that we will take, okay, we will take what? The smallest exponent. We will take the smallest exponent. So between these exponent 1 over 2, minus 1 over 2, 3 over 2, which of them is smallest? Surely minus 1 over 2. So I will take the smallest exponent. Now it remains, I will write all of them as we have, and I will cancel the smallest one. I will cancel. There is nothing. Okay, and I will say is equal to negative. Please follow my way, follow my instruction. First, we took the number. Second, we choose the smallest exponent. Third, I write down all of them, but number 4, fourth, I will write negative, minus. Minus what? Minus here. Here is anything that we have. Maybe positive, maybe negative. I don't care. So this is minus, this is here. This is minus, this here. How about here? I told you I canceled the smallest one. So now In the next part, next step, I will write down this one. You know, negative by negative is equal to positive. So 3 by 2 plus 1 over 2 minus 3x 1 over 2 plus 1 over 2 plus 2. Okay, dear? Now last, you know how to deal with these two fractions, f1, f2, as I told you in the 1.1. So case number 1, so directly I say is equal to 4 over 2 is equal to 2. And here is equal to minus 3, 1, 1, half and half is equal to 1. First case you can also say plus 2. Now again, you finish the most hard part. Now it's easy. We have trinomial. So how we deal with the trinomial? You know, by doing or factoring to binomial. Try to solve this one, please. It's easy, but the important part here is what we have. This as a common. You should take this one as a common between, because this is the smallest exponent. So please try to solve B and 91 and 93. Try to solve this example part A at least 2 or 3 times. Really you need to. Then go to solve 91, then go to B and 93. Thank you for watching this section. See you in the part or the next section in the 1.4. Have a nice time.